we have an example here of a question that falls under margins of error in partial derivative or partial differentiation. In our previous video in this playlist, we had a discussion about how to deal with this type of question, but now we have an example. It says the angle of elevation to the top of a tower is 45 plus or minus 0.5 degrees from a point 450 plus or minus 0.2 meters from the base of the tower. Estimate the height of the tower. Alright. So, since this is the type of question we get, let's draw a diagram so we can just visualize what it is that's going on. So we have the tower here. We need the height of the tower, or I call it h. So we need the height of the tower. We have, they say the angle of elevation to the top of the tower. So this is theta. Theta equals, alright, it's given as 0. No, not 0. It's given as 45 plus or minus 0.5 degrees. But you're going to want to put it in radians, alright? From the point, so here is 450 plus or minus 0.2 meters. Call this x. Now, theta is 45 plus or minus 0.5 degrees. We need it in radians. Now remember, how you do the conversion, an entire revolution contains 360 degrees. At the same time, if you have the radius here, you know the circumference is 2 pi times the radius. So that's 2 pi radians. So 2 pi radians equal 360 degrees. If you divide both sides by 2, you get pi radians equal 180 degrees. So if you divide both pi by pi now, it's degree you want to radian. Let's find out what 1 degree is in radians and then multiply that 1 by 45. So 1 degree is equal to pi over 180 radians. Okay, good. So 45 degrees would be 45 pi over 180 plus or minus, and then 0.5 degrees would be 0.5 pi over 180. So this now is in radians, alright? Let me just erase these things, make space. Alright, now you need to write the formula that connects all of these things, the x, the h, and the theta. But this formula, remember, you're going to find the partial derivatives. So don't put in these numbers that are given. At least don't put them in just yet. Now, what's the formula? Well, from looking at this, we know that tan theta is opposite, which is h, over adjacent, which is called x. So therefore, h is equal to x tan theta. Alright? That's the formula. Now, the basic formula here involving partial derivative, a change. Before we do that, let's find the nominal value. The nominal height. Because remember what they say is that you should estimate the height. the nominal height h would be x. Now remember, the nominal value, which is the average value here, would be the value without the errors, alright? So x is 450 tan 45 degrees. Now, if you have your calculator in degree mode, you can just find tan 45 degrees. But since we're dealing with radians, put your calculator in radian mode and then put 45 pi over 180 and find out what that is. Let me see if I can find a calculator here. Alright. Okay, you have a calculator. Hold on there. Let me see if I can get back my calculator. Okay, so let me put it in advanced mode. So you can see the tan, cosine, and so on, and sine, cosine, and tangent. Where is it? Hold on, advanced mode. Where is the sine, the cosine, and the tangent? Oh, I was wondering. All right. So 45 times pi equal, oh, this calculator, it can be put in radian. Oh, let me see if I get the other calculator that I can put in radian mode. Okay, right, this one, it's in radian mode. Yeah, 45 times, where is pi? Pi. I'm not seeing pi on this calculator. Alright, so let's clear it and go 45 multiplied by, let's use 3.142, right, divided by 180 equal. So, hold on, 45 pi. Let's do that again. 45 times 3.142 should be 3.142 equals that over 180 equal, okay, right, 0.7855. Now, that's in radian. Now, tan, you get 1, right? Now, if we had done it in degree mode and say 45 tan, you get back the same 1, all right? That multiplied by 450 just gives you 450. That's the nominal height. Now, that's 450 meters. Let me put the meters there. Now, it's going to be 45. No, it's going to be 450 meters, plus or minus something. Now, what is that something going to be? Let's write down the basic formula. A change in height is equal to the partial derivative of height with respect to x times a change in x plus partial derivative of theta. No, partial derivative of height with respect to theta times a small change in theta. What's the partial derivative of the height? with respect to x. Delta height by delta x equal, well, we're treating the theta here, tan theta as just a constant. So when you find derivative with respect to x, where a number times x is just the number you get, so it's tan theta. What is the partial derivative of a height with respect to theta? Alright. If you remember, you should remember parts of your table of derivative. When you differentiate sine, you get cos, cos you get sine, tan x you get sec square x. So this is going to be x times sec square theta. Alright? Differentiate tan theta, you get sec square theta. Now, we want delta x. Changing x is equal to what? Oh, 0.2, we have it here. And the change in theta equals, and it must be in radians, remember that. 0.5 degree, which is 0.5 by pi over 180 radians, which is 0.5 pi over 180 radians, alright? Now, that means what we have is a small change in h is equal to partial of, well, we have the partials already. It doesn't make sense if we write it down already. It's going to be partial of h with respect to x, which is tan theta, times the small change in, hold on, yeah, tan theta times the small change in x, which is 0.2, plus partial of h with respect to theta is going to be x sec squared theta times small change in theta, which is 0.5 pi over 180. Let's put in the values now. Small change in h is equal to, now this small change in h is the plus or the minus, alright? Now, tan theta is going to be, theta is what again? 45. Let's assume you have your calculator in radian mode. So it's 45 pi over 180. Tan 45 pi over 180 radian. I could have multiplied it out and get a number, but I just choose to keep using the 45 pi over 180. I put RAD here to remind us that is radian. It's multiplied by 0.2 plus x. X is what? 450? 450 meters. 450 times sec squared theta, which is 45 pi over 180, and that multiplied by 0.5 pi over 180. Alright? So this is going to give you your delta H. Now, let's work it all out. Let's get back to our calculator. Alright. So what we have is 45 times, I don't know why they don't give the pi on this calculator. That's strange. But anyway, you know that pi is 3.142 to 3 decimal places. Hold on. I see some number here. When I press shift, but I still don't see pi. Anyway, I guess that's just the way it is for now. Alright, so we have 45 times, oh no, clear, 45, what's going on? What's it with this calculator? I put 45 times and it's showing me that. Oh, there's pi on it. But let me do this again. This calculator is giving me a bit of a problem. Alright. So 45 multiplied by constants pi. Alright. Good. Divided by 180 equal that in radians. Now let me tan it. It's in radian mode. Tan. I get 1. 1 times 0.2 is 0.2. So what we have here is just 0.2 plus. Alright. Now the next thing will be 450 times, we're going to need to find this thing here now, sec square of this. So we have 45 multiplied by pi over 180 equals, alright. We're going to find the sec square of this. Now sec is 1 over cos. And then square it. So we have this, let's cos it. We have this. 1 over this. Okay. Then square. Square. We have 2. See that? It's times 2. So it's 2 times 0.5 pi over 180. So it's 0.2 plus, changing h is equal to 0.2 plus. Now let us work all of that out and see what we get. Alright? Alright. So here now, let's clear it. 450 multiplied by 2 multiplied by 0.5 multiplied by pi over 180 equal 7.854. 7.854. Alright. So the change in h is equal to 7.854 plus 0.2, that's going to be 4, 5, 8, 9, 10. Bring down the 0, carry 1718. So we have 8.05 to 2 decimal places. So the height is equal to 450 plus, let me rewrite the 450 plus or minus 8.05 meters.